Hello everyone, this is Anurag Dutta from India, and today in the ICCIKE 2023 conference, I would be presenting the paper Stella Classification vis-a-vis Convolutional Neural Network. Firstly, I would like to thank Amity University Dubai for hosting the conference and making all of the arrangements. So, moving forward, this is a little bit of introduction about me. I am currently an undergraduate at the Department of Computer Science and Engineering at Government College of Engineering and Textile Technology, Shirampur, Calcutta, India. So let me begin with the paper presentation. The first slide is about the introduction of the work or a little bit of summary of the work that we have put forward in this paper. The area between the celestial bodies and beyond the Earth's surface is known as outer space or simply space. In addition to electromagnetic waves, we have magnetic forces, neutrinos, dust, and cosmic waves all over the space. There is a relatively low concentration of particles in this space, and most of which are hydrogen and helium rotating with high velocity, which are subjected to electromagnetic radiations. So, moving on, this is the outer space. This slide we will be talking about the outer space in a little bit of more details. The radiation level from the Big Bang established a temperature of nearly 2.7 in the entire universe, which is considered as universal all over the like entire universe, right? It is believed that approximately half of the baryon mass in this universe is composed of the plasma that exists between galaxies. This plasma has dynamic temperature that is getting close to millions of kelvins and a numbered density of fewer than one atom of hydrogen per cubic meter. The accumulation of matter in specified regions leads to formation of astronomical objects like galaxies and stars. In this paper, we would be classifying on the basis of some spectral imaging between celestial bodies that whether they are galaxies or stars. Since this work is regarding stellar classification, here we will be considering the stars and galaxies in the outer space matrix. A star is a sort of heavenly sphere that is composed of a luminous globe of plasma that is bound in place by the star's intrinsic gravitation. Stars can be distinguished from the other type of celestial bodies in several ways. The sun is the astronomical body that orbits the galaxy in the opposite direction of Earth. At night, there exists a significantly large number of extra luminaries that are visible with the naked eyes. However, because of the enormous distance between the Earth that seem motionless points of light in the outer space, it is quite difficult for us to distinguish that whether a glowing celestial body is, let's say, a star or a galaxy. Astronomers have worked tirelessly to build star catalogs which list every single known stars and provide conventional designations for stellar names. The observations are made possible by the observation of a star's apparent brightness, and astronomers have determined stellar classification characteristics such as mass, age, metallicity, variance, distance, and kinematics across space by performing inferences of a star's apparent brightness, spectral response, and modifications in its position in the sky with time. So, for this classification, we made use of convolutional neural network. This slide is a little bit of introduction about what convolutional neural network is, and in the coming slide, we'll be talking about the model of the convolutional neural network. So, a convolutional neural network, often known as ConvNet, is an artificial neural network that is typically utilized to analyze visual data or imagery data. Convolutional neural networks are shift invariant or space invariant artificial neural networks because of their convolutional kernels or filters slide along input features and construct translation equivariant feature maps. Due to the downsampling process that most convolutional neural networks perform on the input, these networks are not invariant to translation. This is contrary to what one may expect. They can improve imagery and video recognition, categorization, dissection, and decision support systems, and many other fields which could be improvised in various domains like natural language processing, mind interfering, then financial analysis, and many other fields. So this is about the architecture of convolutional neural network. CNNs have three layers: an input layer, a hidden layer, and finally we have the output layer. The activation function and final convolutional layer hides the input and outputs of feed forward neural networks intermediary layers. CNNs have hidden layers that contain layers that conduct convolutions. In most cases, this will consist of a layer that carries out a dot product of the convolution kernel with the input matrix for the layer. This is a pictorial representation of the architecture of CNN. Here at first we have the input imagery, which has been transformed into convolutional layers, and from them it is been converted to pooling. And finally we have this kind of layer structure from which we get the output. The data set. So in this paper, we had made use of a data set, and the data set is actually taken from ARIES. So it is located in Nainital, Kumaon, India. The Aryabhata Research Institute of Observational Sciences is a leading research organization that focuses on astronomy, solar physics, astrophysics, and atmospheric science. It is self-governing organization that operates under the Department of Science and Technology of the Indian government. ARIES is researching a variety of areas associated with the sun, stars, and galaxies. ARIES has made some important contributions to the scientific community, most notably in the field of star clusters and gamma ray bursts. In this article, the convolutional neural network is proposed to be trained by making use of an imagery dataset of stellar objects. ARIES helped us with such an observatory data. The authors of this paper believe in sharing is caring, so we have made this data set openly available at this particular GitHub link. Anyone can have a look in this data set. This is a little bit of chunk of the data set that have been taken from the original one. So these are the imagery of galaxies, and these are the imagery of the stars. So there are like several images of the stars and galaxies which are present in the link that we have shared previously. So coming forward, here we have the results with us. So for the results, we would be considering the precision recall curve and the confusion matrix, because both of them are considered much important in machine learning and artificial intelligence. At first, for the support vector machine, we can see that the precision recall curve is something like this. And for the confusion matrix, uh, these two sectors, like the bottom right sector and the top left sector, are considered quite important. So the bottom right sector is the true scenario. Like the considered case were, like, let's say the result that was given was probably a celestial body was considered to be a star, and the actual scenario was it was a star. While in the other case, let's say the model predicted it to be a galaxy, while in actual scenario it was actually a galaxy. So these are the true scenario and false scenario. So for SVM we have 606 instances of true scenario, while 31 instances of false scenario. For random forest we have 606 instances of true scenario, while 44 instances of false scenario. For Kenya's neighbor also we have 596 instances of true, while 39 instances of false. For Gaussian naive Bayes we have 479 instances of true, 61 instances of false. For logistic regression, we have 551 instances of true, while 59 instances of false. For the decision tree, we have 518 instances of true, while 82 instances of false. And finally, after this, we made use of the convolutional neural network, and these are the epoch versus accuracy results, or the plots, and the loss versus epoch results. So in the left hand side, I have with me the accuracy versus epoch curve, while in the right hand side I have the loss versus epoch curve. So here we can see that the accuracy is, at first it was decreasing, and after that on increasing the number of epochs we are getting a good accuracy. These are some of the references which we made use of for preparing the manuscript. Thank you for giving us the opportunity to present the paper. Have a nice day.